This is Fred chapter 16, and the chapter's called Fast Freeze, and it starts on page 108, so you can put that on your paper so I will know. Okay? After buying his pizza button, Joe wandered back to the ice cream machine. He couldn't wait for the ice cream to be done. He briefly looked at all the dials and gauges on the front panel, but he didn't understand them. Then he spotted the freezing lever. He had seen Fred pull down that lever with 5 pounds of force. He thought to himself, the colder the setting, the faster the machine will make ice cream. And Fred had left the lever way down here. So Joe put his hand on the lever. And he thought for a moment. He pulled it down to 10, and the machine rumbled a little louder. Joe put his elbow on the lever to add a little extra pressure, and the lever stayed at 10. Just for fun, Joe hopped up and sat on the lever, and here are two inequalities. So you might be thinking, what are two inequalities? Inequalities is the greater than and the less than sign that we've been working with. But they're called inequalities because it means one side is greater than the other side or less than the other side. In this case, Joe's weight is 100 pounds, so Joe's weight is greater than 100 pounds. And here Joe's IQ, everybody's IQ has a number, is less than 100. Now, the handle broke off and Joe couldn't pull it back up to 9. The lights in the Pi 1 dimmed. The lights in the room dimmed and flickered. The ice cream machine was using more electricity than all of Kitten's University normal uses. But Joe was right about one thing. The ice cream would freeze faster. How fast? And the bells and the lights were flickering. And the ice cream was ready. Alexander ran over to the machine. The lever was broken and couldn't be moved, and the bells keep ringing, and so the only thing he could do was just unplug the machine, and then it was quiet in the room. Everyone in the room was looking at Alexander, Joe, and the machine. After a moment, Alexander announced, "The ice cream will be ready a little earlier than we thought. If everyone would get a bowl and a spoon from Stanthony, we can begin the Math and Pizza Conference with dessert." Now, 800 people were expected for the conference, but it was still early. There were only 200 here when the ice cream was passed out. Each person got 4 times as much. How much would that be? See, we expected 800. There are 200 here. And how many more people are there? Each person is going to get how much more? So 200 goes into 800 4 times. 4 times 8 is 800. That's 0. So we have 4 times as much as we need at the moment. Now we have 6 things that need to be explained. So the first thing is, how did they get the ice cream out of the machine if it was unplugged? Alexander couldn't plug in the machine, otherwise the machine would continue to freeze and the bells would continue to ring. Instead, he took off a top panel, reached down, and scooped up the ice cream. The second question is, how much ice cream did each person get? The original recipe, if you remember from Professor Eldwood's book titled Making Ice Cream the Modern Way, was for one serving was 8 ounces of fresh squeezed cow's milk. Oh, fresh milk straight from the cow. Here's a fun fact. Do you know that Mrs. Hillman and her husband, they used to have dairy cows? Yep. We could have gone there if they still had the cows and gotten you each a Dixie cup full of fresh milk right out of the cow. Oh, yum. So, 1 serving of fresh cow's milk was 8 ounces, which equals a cup. 8 ounces equals 1 cup. These are measurements that you would use in cooking. We've talked about these before. So each person, if they got 1 cup, well, in this case, each person got 4 cups, which equals 1 quart per person. So 1 serving, which was 8 ounces, equals 1 cup. In this case, each person got 4 cups, and 4 cups equals a quart. So those are some basic measurements. Third question. After a quart of ice cream, would anybody be able to eat any pizza? I mean, that's a lot of pizza. They might not. But if there was going to be 600 people who didn't have any ice cream. Hang on, my dog is whining and crying. Hold on. Okay, I'm back. My dog wants to eat my kitty cat. She heard my kitty cat and went after my... Yep, can you hear her barking? Yep. Okay, I'm back again. So, we were talking about who would be hungry after the eating a quart of ice cream. And we talked about 600 people haven't shown up yet. 200 are there, and we expected 800. So we had 800 minus the 200 that are there, and that equals 600 people who aren't there for the ice cream, so they will be hungry for the pizza. So the fourth question is, how can you make ice cream from fresh squeezed cow's milk? Was Professor Eldwood wrong? Well, he was wrong, because he left a step out of the process. When a cow offers you some of her milk, and only we know female animals give milk, part of it is cream and part of it is skim, which is non-fat milk. A glass of fresh milk will have a thick cream at the top. Oh, I'm trying to draw a cup and it's not working. We'll have fresh milk. We'll have thick cream at the top. Okay. And thinner skim milk towards the bottom. Now, if you go to the store, now the milk you buy at the store has been homogenized, and it'll say so usually on the carton somewhere. And the cream and the skim milk have been scrambled up so the cream doesn't float to the top. Professor Elwood should have written cream instead of milk. That's what he needed. So the fifth question is, how did the lever scale that was at 10 suddenly get all the way down, and I can't even get all the numbers on here, to 24? Originally, this machine wasn't an ice cream machine. You can't go to a regular store in Kansas and purchase an ice cream maker for 800 people. This particular machine was used in a science lab to study, let me write the word, cryogenics. It's the study of super low temperatures. Okay. Cryogenics. And cryogenics goes far beyond refrigeration that's needed to make an ice cream machine. When they sold it as an ice cream maker, they covered up that part of the lever so that no one would see it and know that they could get that cold. Couple of fun facts. If Fred wanted to explain to you that the fat particles in the cream are emulsified, oh, that's that word, emulsified, then he would have to explain what emulsified meant. And the process of suspending one liquid with another creates an emulsion. And then Fred would have to talk about why some liquids, like water, don't get along with other liquids like oil or grease. For example, if you get oil or grease on your hand, water won't take it off. But if you use soap, it will. So that's an example of something emulsified. Now, the other one is in the cryogenics lab, where everything gets really cold. We can talk about helium because helium has really weird properties. Helium doesn't become just a liquid, it becomes a super liquid, and it will flow without friction. So if you had a cup of coffee sitting on your desk and you stirred it and then you took out the stirrer, after a couple minutes the coffee would stop moving. But superfluid helium doesn't stop moving even years later. It just keeps going. That'd be a fun thing to look at in science here a little bit later. Okay, so the sixth thing that needs explaining is your first YTTP, your turn to play question. So here's a handy chart for serving 800 people. We have the levers at 3 and the ice cream will be done in 84 minutes. The lever's at 6, the ice cream's done in 72 minutes. But if the lever's at 24, when would the ice cream be done? So what we know here is that we have 2 points. We're talking about a graph here. So we have the 3 and 84 is going to be 1 point. We have the 6 and the 72. That's the next point. And we only have the 24, and we need to find out what goes with that. Okay? Okay, so very neatly using graph paper, you're going to make a chart like this. It needs to go to 24 on the bottom. The X is going to, that's the lever points. And on the Y line, which is going to be minutes, it needs to go to at least 90 or 100. Then you have to plot the 2 that you know. The 2 plots that I gave you already, which was 3 and 84, 6 and 72. And so plot those out, make sure you keep everything nice and neat, and then you're going to use your ruler to see where it's going to cross with the 24, okay? So it's going to go 3, 6, and then 24, and we have 84 and 72 over here. And we don't know what the number is going to be until we draw our line and we see, okay? So 3 going to be here, and so we have 3 and 84, so that first one's going to be about right here. 3 is here, and 84 is there. Next I have 6 and 72, so 72 is going to be about right there. Okay, and then the next one that you have to figure out is the 24. So you're going to have to draw your line from there to the 24 and see how many minutes that's going to take. Okay? So when you get done with, that's the only question. There was only one question today. Ask me for the worksheet to go. You'll practice some addition problems. That's it for today. Yay!